Hey everyone, this is part 4 of the test review going over test 4 material. We are now at chapter 24, Geometrical Optics. In this chapter we talked about mirrors and lenses. So the first thing, the concept that you need to know is the focal point. Whether it's a mirror or a lens, if an object is far away, then the image is formed at the focal point. So if you have a converging mirror, for example, and this is the optical axis here. If the object is very far away, we learned that the rays coming from that object are basically parallel. So again, the object is very far away. We don't really see it on here, but we have these incoming rays that are parallel. And all of these incoming rays, they will, when they hit the mirror, they will reflect through that focal point. And that means that the image is going to be formed at that focal point. So that is true for a mirror or a lens. We have a converging lens like this. If the rays are parallel, then they're all going to refract here, and they're all going to refract at that focal point as well. If you look at the thin lens equation, which is also called the mirror equation, 1 over P plus 1 over Q equals 1 over F, where P is a distance of the object to the lens or mirror. As you can see here, if you have a mirror, the object is over here, so that distance is P. Q is the image distance, so the image is formed here. That's the image distance from the mirror to here. And F is the focal length. The focal length is a distance from your lens or mirror to that focal point. So that's the focal length. So you can see from this equation that if your object is very far away, then it's as though P is equal to infinity because it's very far away, much further than those numbers. So 1 over P is going to equal 0. Then we get 1 over Q equals 1 over F. And this shows us that Q is equal to F. So this shows us that the image distance equals the focal length. This tells us that the image is going to be formed at the focal point. And then we talked about flat mirrors. So for flat mirrors, you have certain properties that are always true. This is your flat mirror, this is your object, this is your optical axis, or your just a horizontal line here. If your object is here, then that's P here. The image is going to be the same distance Q away. If it's that high, the object, the image is going to be that high. The magnification is 1. We see here that magnification is the image height over the object height. So if the magnification is 1, that means that the two heights are equal to each other. They're the same height. And the image formed is always virtual and upright. We know that the way that this was formed is that your rays were reflecting and that you trace those rays backwards, and where those rays intersect is where you form that image. These rays that are reflecting off the mirror are never converging, they're never intersecting, so you trace them back, and that's a virtual image that you cannot capture on a screen.